So today's agenda would be like, I'll just give you a brief description about myself, and then about the analytics, who are using it and who can participate into it. Okay. And then my core area of technical part that I would like to discuss today is like application of time series analysis, forecasting and clustering using the same. Okay. And then maybe I'll just quickly go through how I got my break into a data scientist role, how I started my journey in the field of analytics, right? And maybe at the end of the day, I'll just give you some of the points, maybe what can help you. You can, I mean, there would be many points. Maybe you can just follow a couple of them, and that might help you in your journey as well. Okay. Yeah. So this is all about myself. So I am having overall 8 years of industry experience. Okay, I worked with in healthcare, CPG, manufacturing, and IT a bit. I started my career with IT. Okay, so my formal qualification, I had a BTech in electronics and communication. I started my BTech in 2004 and 2008. And then after that, I joined Infosys as my first company, and this is where I started as a software programmer. Okay, before before I get into analytics, right? Okay, and then with Greatlex, I got connected in 2014 when I started my PGPBA in Greatlex, and it was excellent 1 year that I spent okay with Greatlex, and I'm still able to connect with Greatlex, so I'm really happy, okay, for that. Okay, so I mean, what kind of roles that I have played in the industry? I mean, it may be a little bit of in IT and a little, I mean, maximum in the field of analytics. So I had an opportunity to work as a project management for a product development project, right? And also I worked as a consultant, and I worked as a pure data scientist, and also I worked as a programmer, right? I worked as a junior programmer initially, and also I worked as a senior programmer. Okay, so the kind of tools and that expertise that I had is in the field of analytics. I have mentioned it here, like some of advanced analytics, machine learning. I worked with SPSS modeler since I'm part of IBM right now, so I have to work with SPSS at some point of time, and I did so, right? But my personal favorite is R. I love to program with R, and also I used R Shiny a bit for building some visualization with using R. Right. Also, I had a chance to work in a little bit of Python, and also there is a new product that coming from IBM that is called WDP, Watson Data Platform. So this is a completely new. It's like a platform as software. I mean, that analytics as a platform, right? So the way Azure and Spark, ML, all are coming. So IBM has its own platform that's called WDP. Okay, and also I had a bit of opportunity to work with Spark. Okay, so most of the technologies that I used, or mostly I applied in my previously when I was working with Philips, and also I was a part of Philips market research. So I used mostly R and a bit of SAS, SQL, and all, right? So, and then also I worked as in IBM. I worked in a little bit of CPG, whereas I had to do attribution modeling. Okay, and then in IBM I had opportunity to build a couple of product, and one of the product that I built from scratch, and that's called Ignite Defect Predict. So maybe it's already implemented for a couple of clients, and I think within the next 6 months you might be able to see this product in market. Okay, and mostly it's related to how we can forecast defects in the field. I mean, like in an IT software development project. Okay. And apart from that, also I worked in a little bit of resource management and demand planning, how to predict the number of people you want to hire in a company, or people are getting rolled off from a project, or they're leaving a company. So it's like kind of human resource management and demand planning, right? So this is also again a tool. I mean, it ended up a tool. It was not meant to be a tool, but it was ended up as a tool that we worked with. But in the when I started my career with Infosys, I think this is where you guys will be very much interested, right? So when I started my journey with Infosys, I was a programmer. I worked as a programmer. I learned Java, I learned C, I learned Unix, I learned mainframe as well. Okay, and In ITC, actually, this is where I came into. I started working with as a part of analytics support team, right? So this is where the transition happened. So, but till ITC, I still consider okay, fine. It was a bit of IT side that I worked. Okay. So when I was in IT, mostly I worked with CEGL, that is called Enterprise Generation Language. I used DB2 as a database. I used Oracle a bit also. So there are multiple tools and technology that I had to use. So, but it's never it's always a strength at the end of the day, because when you have a strong programming background, you can that gives you extra added advantage in the field of analytics. Okay. So yeah, that's it about myself. And right, let's get into that why analytics and what is this buzzword and all. Right. So I think every one of you follow the Gartner's Magic Square, right? Gartner's is the firm. So if you haven't heard of it, you might have watched that movie called I think yeah. Anyway, it's a Will Smith movie. It's about Gartner. I forgot the name right now. Okay, so yeah, so mostly if you see the Gartners, the way they predict what is going to be the next 10 years market leading technologies, or who will be leading who are the leading companies, or what are the leading sectors or areas. So various kind of forecasts. They have a magic square, right, where they give all those kind of insights. So a few things that I learned from there, I observed. So what everyone is saying, so why the industry is changing, and what is analytics all about? Who is using it? So the question is, who's not using it? Everyone is in analytics. Why they're using it? Why they're not performing the way the traditional companies used to, or the industries used to function? So basically, three disruptions that happened in the last 1.5 decades. The first thing is internet. Internet, what has internet made? It's just made the information free, copyable, and it's just anyone can learn anything right now. It's everything open source, and it happened because of the reach of internet, right? Now, in drugs or in healthcare term, I mean, pharma, we say it's loss of exclusivity, right? So that means when one drug from brand, it becomes a generic. So it is no longer a branded. So information is no longer a brand. So the traditional companies, for example, if you see, there are a lot of companies who used to sell data, who used to sell maybe, for example, Visual C++. You might have to get a license, or even for some of the software languages also, if you are using, you have to pay some company. It is no longer like that. You use any data, any information, it's almost free nowadays. So that has made a big impact, right? The second thing is like the mobile devices. So everyone from a rural India to the top of, top city like New York, everyone is connected with mobile. So you can send a message, you can build an app, and someone can access from US, right? You can build that in some village of India also. So everyone is connected. So companies can now reach to any of the companies, any of the people directly. So they don't need a medium like TV, advertisement, or anything to reach anyone. So reach is a global reach. That is almost free, right? And the third thing is cloud computation. What cloud computation brought in is the infinite computation power, right? I mean, it's a distributed platform. You run no matter what kind of algorithms. Earlier, for example, SVM, that is called, that's a very popular algorithm. I mean, right now it is not no longer popular that much, but it used to be very popular in the last 4 or 5 years back also. So no one used to use SVM, even though it developed, I think, in somewhere in the early 90s. And the only problem was that there was no computation power. So most of the time, the models never used to converge. I mean, it used to crash. Nowadays, since the moment the computation power increased, SVM has become like most popular algorithm. So right now, there are gradient boosting and all. People talk about a lot of other neural net, deep learning. So, but yeah, SVM reached to that glory because of computation power. So now cloud has given you infinite computation power virtually, right? No, so these are the three things. The companies has to change. They has to, every company, they have to like incorporate analytics as a core practice. It is no longer the exclusivity that you used to have on information or anything that used to run your business. Rather, it is the excellence of the product development. how well you build a product. Anyone can build the same product, but the question is how well you can build the product. If you see Google, their products are excellent. No one can reach to that level, right? And that's why they are so ahead of anyone else. So it's excellence, right? Now, who can participate? The way I'm saying, like the information was exclusive to the companies. Now, if you see the way few years back, maybe 10 years back or 15 years back, if you are from IIT, if you are from some top US university, you are from ISC, you are welcome in the field of analytics and maybe cognitive computing or AI, artificial intelligence, right? Now the problem is, as per Gartner, by 2018, you need 1 million data scientists. How do you feel that? So there is no way. You need skill-based people, not the degree-based at times. Okay. So if you see the Microsoft JDs now, everyone, like Foodpanda to Microsoft, everyone is hiring data scientists. But if you nowadays we go to Naukri and you open a Microsoft requirement, that only premium colleges tag is no longer present in the JD, right? So that's what that's enable a huge base of people, right, who can just grab those opportunities, provided they have the right kind of skills. What I'm saying, the statistics, machine learning, deep learning with Python or Scala, and all sort of. So which are most of many of you know those skills, and some of you may not be, but definitely you can learn those, and you can challenge those kind of job opportunities and challenge most of the people from top tier 1 universities. Okay, so it is skill-based. It is not a degree-based job opportunity anymore, right? So, and again, if you see, for example, the way I'm saying, because deep learning, this term is many of these. It's there. I think if you are connected to any of the analytics group or in Facebook or AI group, deep learning is everywhere. Everyone is calling deep learning, deep learning, deep learning. Now, in 2014, there were 0 jobs in deep learning. Now, it has grown to 41,000 now. Deep learning is very niche. Only few people from masters and postdoc used to work with those things, but it's no longer that. Anyone can run deep learning. They can use deep learning. They can build systems with using deep learning, right? But the point is, I have learned deep learning. I have learned Scala, Python, and all. But am I secure? To what extent my job is secure, or is it going to be something else and something different in the future? Yes, it is still not secure, right? So the point is, what I'm trying to make. So Google is trying to train an artificial intelligence system that will be able to create its own, generate artificial systems. That means when you are saying that automation, so this is what is about. Automation happened in IT. Automation is going to happen in analytics as well. So the point is, how can I secure my job from such AI-driven automated systems, right? So there is still the scope for people with excellent business domain knowledge, people with excellent consulting capability, because you have to sell the products no matter what you build. And there are people with excellent programming skill. If you can learn the programming, if you can learn the statistics, if you can learn the mathematics, you can build some. You can always beat those systems, because it will be, whenever you are building a training automated system, it's a generalized system. It is not generalized system. It is very specific. It needs a lot of customization to fit the data for that model. Now the point is, the scope is there for every small, very niche kind of work. You need good and sound programming and model building approach. So you are there, provided you learn the things. You learn how to program and how to build models, right? Okay. So yeah. So this is where actually I wanted to get in. So this is my whole point of interest tonight. Okay. So last few years, I happen to be working a lot of forecasting. And forecasting, when you say, we call it time series and time series so analysis. And I'm not saying it's a forecasting. I'm saying it's a time series analysis and its application. So what is time series? Now, something, in a very simplest, naive statement, I would say, if I have data points which is ordered by time, it's a time series. For example, um, what is I mean, in my neighborhood, there's a guy who sells some vegetables every day. So if I ask, can you tell me last 1 month, every day, how much vegetables you sold? And you might say, okay, every day I sold, this day I sold for 100, this day 102, 103, blah, blah, blah. For next 1 month, you might give me a big data. Okay, not big, it's a 30 data points. And you said, okay, these are every day's data, and these are the dates, and this much of amount sales I have done. So I have a sales data from that person, which is a time series, right? And he might ask, okay, can you please tell me what would be, how much I'm going to sell next week? So that's why when I have to start and thinking and trying to analyze that time series. Okay, now, so this is quite interesting. So whenever we say time series forecasting, we try to think some kind of very niche, and very something very knowledge that is limited to some very specific group of people, right? Especially people working with directly to the CEO and others who needs to forecast revenue and all. So, but to me, I see the time series a little differently. To me, time series is not only time series. So it's a signal, it's a sound, it's a waves. So here, what I'm trying to do, I'm trying to show you various perspectives. So I have a perspective of a statistician, I have a perspective of an engineer, I have the perspective of a physics students, right? Yeah, I mean, most of us from class 11, 12, we have to study physics. Right? Some of you may not be, but again, you might have studied in class 9 or 10. Okay, so it was there, right? And I think the last one, every one of us experience, right? So at times we want to be nature lovers, so we go by a pond or a lake. Okay, it can be, I mean, wherever we find some still water, somehow we get some kind of, in a call to just throw one stone on the still water, right? So the moment I throw a stone, what happens? I see ripples, right? So these ripples are nothing but waves. So these waves, and then what happens? The moment I throw one stone, I mean, if someone is sitting by me, okay, he or she also wants to throw one stone on that lake, okay, and the still water creates another ripple. And then what happens that when both the ripples are completely like in a circular pattern, but the moment they hit with each other, so they just they just create a different kind of shape. So that's what, I mean, this is happening. So the ripples from one stone and the other stone, they just are overlapping with each other. This is in physics term, we used to call it superimposition, right? Okay. And then they're creating some kind of resultant ripples here, right? So from a physics student's perspective, how we saw the things, okay, we say, okay, what is sound wave? So sound wave definition is, oh my God, it's something very, very complex, right? So it's a pattern of disturbances caused by movement of energy traveling through medium as it propagates away from the source. So let's not try to understand that. Okay, so what happens? I have a tuning fork. Many of you play guitar, or I'm sorry, yeah, I have a tuning fork and I have a hammer. So I'm just creating some wave, some sound. If I knock on my tuning fork, I'm getting it, and also I have hammered a nail, and I'm also getting one at the same time. I'm getting some sound from there. Right? The moment, but at the time, I mean, if I record that, and I should get a resultant of both the things. So basically, the sound of my tuning fork is having some kind of noise. The noise is nothing but the hammer. So noise, here I'm saying it noise, but it may not be a noise, I mean, from different perspectives. So, so they're both are creating a resultant wave. Okay, so this is what is my resultant. Now, well, you might be able to think, well, what is this related to the forecasting? Okay, let's right now I don't know how it's related, but maybe we'll try to figure out in the next 5 minutes. Okay, now let's say from an engineer's perspective, a lot of you guys are maybe electrical engineers or electronics engineers. Some of you maybe or from electronics field also. So what do you call a signal, right? Well, instead of wave or ripple or something, we call it a signal. Now, signal is like, so this picture here, the signal is nothing but your heart. It's a pulse. Okay, so if you see someone in the hospital, so there's a PCMS, right? So patient care monitoring system. So there you might see this kind of pulse rate is going on. Now, if I use the Fourier transform, right, in our engineering days, we might have heard that term, Fourier transform. So what it does, see, Fourier transform, let's first forget what is this Fourier transform. So what we can say, when I play music in my car deck or somewhere, so I see some kind of those bars, right? Those are going up with the bars and treble. So those are basically nothing but the frequency along with the amplitudes, right? So this is what. So if I apply Fourier transform to such a music or a harp pulse, so then I get this kind of spikes. So these are like nothing but this denotes the amplitude and the frequency. Okay. So this is one again. I mean, is it a forecasting? Let's figure out. Okay. And from a statistician perspective, so what is the time series? I already said it's ordered by time. The data points are ordered by time. So this is my time series. And if I apply a decompose function in R, so what I get a trend. Okay. So which is trend is nothing but how whether it is going up or going down. That's what I'm calling a trend. And I get a seasonal component, right? So seasonality is nothing but, right, for example, every winter, your selling of sweaters go up. And then in summer, the sweaters and any kind of winter go down. So there's a up and down, which repeats again and again every year. So that's why it's called seasonality. It changes with the season, right? I mean, it repeats with the season rather. And the third component is like, even we don't know. So it's a random part. So this is something that is unexplained. So this is one of the decomposition that there can be many other form of decomposition. So this is the very basic, most of the time we see. So this is, I not like to get into much detail. So it's simple. It's a multiplicative model. Okay, and what we do, we just first try to make it stationary. So what do you mean by stationary? Now, if you see this wave, right, this is kind of going up, and it is not limited to some particular range. For example, this wave we can see it is limited to a specific range. So in statistical term, we say okay, it is heteroscedastic, and here we can say it's homoscedastic, or it is not scattering beyond certain range. So it's quite stationary. So we have some certain taste, like we call it Dickey-Fowler stationary check, and then also we do a white noise. White noise in the sense the data really has some kind of forecasting ability, whether we can forecast with the data, right? So if it is plain simple white noise, we may not be able to do any kind of forecast. So that taking the mean would be the best forecast in that case. So it's basically noise, right? So that we need to do certain quality check, and those we need to stabilize that waveform. And after that, what we do, we try to identify what are the PDQ in an ARIMA. So what is ARIMA? A-R-M-I-M-A, right? So AR stands for autoregressive, MA stands for moving average, and I is the difference, right? So when we try, I forgot to tell, so how do we make it stationary? So one of the way to do it is like by taking difference between each time data points, right? So if I take a difference 1, and maybe I get, so I would say my D, the value of D is 1. And the AR and MA we can find out by creating ACF and PSCF. So ACF is autocorrelation function that is available in R. PSCF is a partial autocorrelation function, right? So I have just put, it's a much complex than that. This we have to do iterative and find which is the best fit and all. But on an average, I mean, very simple way, we can say, so this is how, if you see this table, we can say which model to use. It's an AR model, pure AR or pure MA, or it's ARMA. Okay, AR, MA both. So we can figure out by looking at this. So I think, I think this is where I will sum up for this forecasting part. And so this is the result, and this is also one linear regression equation I have given. So how my linear regression, for example, I wanted to focus the demand. So demand and then demand of lag 3, the week numbers, the month end flags, and all were my dependent variable for the linear regression. And this is how I predicted. And okay, yeah. So this is another another project that I worked on, this time series clustering. So this is again interesting. Many of you know what is regression and what is clustering. Clustering is nothing but unsupervised learning methods. Now, we can actually use clustering techniques, principles for clustering time series data. So what does it mean? So I'll just give you one example, right? So let's say we have stock market data, right? So the stocks are there. Now, each one is like a time series. If I take last 5 years stock data or 1 year's data, daily return data of the closing price, okay, so that can be one signal, or it's 1 year. Each of them are like 1 year time series. Now, if someone asks me, maybe a fund manager or someone, can you please cluster or segment or group the time series data into segments, right? Into groups which are related. So why does the fund manager need to do that? Maybe he wants to know which stocks or group of stocks that he can invest, which will give a long-term return. Maybe the stocks which he wants to invest and get a short-term return, you can just quickly buy and next week you can sell, and maybe a medium-term return and all. Which are the stocks he doesn't even need to invest because there is a high chance of losing money, right? So this is where you can use time series clustering methods. So yeah, so I need to know. I mean, the fund manager needs to know when he has to or which stock segment he has to invest, right? So we can use the Fourier transform I was saying, right? You can get the frequencies and amplitudes. So that is basically nothing but, so here I have one example. I just try to understand this example. It may be like, so I have two waves. So these are the two waves I created using one small applet in the wave. And so these waves, they're just superimposed. If you just take a sum of these two waves, you get this resultant one. In other words, if you take this result, I mean each signal, and break it up into n number of different waves, and if you find what is the amplitude and what is the frequency and all, so basically you can create a data set or a training metrics, right? So which will have all the stocks and their corresponding features, right? So we'll call these frequencies and amplitude as feature, right? So using that matrix, if we can apply some kind of unsupervised clustering methods. So the main point is building that feature matrix, right? So, and then if you apply some kind of unsupervised parameter, I used a hierarchical clustering, and I used SOM, so that is called a self-organizing map. That's unsupervised neural net. So for creating clusters, so then we can come up with some clusters which are related, which will contain the related time series, right? So similar kind of waves or signals will be in each of those clusters. And then by analyzing those clusters, whether they're going up because there will be similar kind of waves in each cluster, which are like which having heavy fluctuations, right? So which will have very high frequency data, in the sense they will fluctuate a lot. So we'll call them as like kind of short-term investment kind of. So you just sell when it is low, and you buy it when it's low and you sell it immediately in 1 or 2 days. So yeah, so that's how you can use Fourier transform and frequency metrics, frequency and amplitude metrics, and you can do a dimension reduction by applying PCA or some other techniques, and then you can apply some kind of clustering methods. You come up with clusters. So this is one of the POC that I did. Okay, and yeah, it's really it's technical, but it's quite interesting the way, yeah, if you ask me 3-4 years back whether I'll be able to do something like that, but that's an answer I would have given no. But it's a continuous learning. So, and that, maybe enable you to do certain things that you may not even think of, right? Now, let's, maybe we might have still, what is this matrix, what is this Fourier transform and all? So to make life easy, so I just given one example. I just copied it from the web and find it's the best example, so I keep it as it is. So everyone, we love smoothies, right? So if I give you one smoothie and I ask you, can you find the recipe? So you say, yeah, okay, fine. Let me try some kind of analytics filter, and I will get each of the components, maybe the milk, the banana, the sugar, and the fruits and all. So separate them each from the smoothie, and I can have all the ingredients, right? And then if I again mix all those ingredients together, I'll have the smoothie. So this is what it's like. So I get one signal, I get one stock signal, stock market data, right? I break it into multiple ingredients, which it is built with. The ingredients may be trained, the seasonality and all, or the frequency or the amplitudes, whatever, in whatever way you want to transfer those ingredients, and then you just make it together and get your smoothie. Okay. So this is all about my the time series that yeah. So this is where I put things in details, but I have mostly, I think, discussed all the things, right? So the techniques, what I use, that R, A50, and the self-organizing maps and all for this particular POC. Okay. Now the question is like, these are some of the might that I can suggest or I can advise some of you. So maybe just try to follow if you can. I mean, that might help. It helped me a lot. So the principles like that so one thing that I already said, okay, you learn the mathematics, right? So the people who will take your interview, or people who will be managing you, or people who will be working with you are some kind of pro in mathematics or stats, or they're from IIT, ISC, or top economics schools, and their statistics foundation is very strong. So if you want to please them, just stats is the best way. Okay, it's difficult to bluff them the other way. Okay, now the second thing is, most of us, when I take interviews, okay, a lot of people, they say, I know this machine learning and all, but the point is they often do not have the basic statistics concepts clear. So, and that's why they get straight away rejected. So just machine learning is founded on, I mean, this is a foundation of machine learning is statistics. Okay, so just don't avoid it. Okay. The third thing is programming. A lot of you people are from, I think, as per the data I was seeing from Great Lakes, so it's like around 55% people or to 60% people are from IT background. So at some point of time, you have done some kind of programming. So just continue to. It's an advantage. It's not a disadvantage that you are from IT. It's an advantage. Just learn the programming to a different level, and it will help. Okay, and many of you do actually, right? The third thing, I mean, another thing is business understanding. So you are into business analytics, so you should be you should know the business, right? So statistics and programming, I say it's like a formula and tool. But if you don't know business, okay, you are definitely applying it at the wrong place. Okay, and one of the most important thing that I see is it's like your imagination power, right? That's what helps you to connect different things together. Okay, different industries or different kind of situation, and you connect them and you try to solve a problem. Right? So what I say is like, this is what actually helps you to create a difference in your day-to-day work, right? So I mean, in analytics, you should get challenged every day. Okay, and if you're not getting challenged, you're not doing analytics. And if you have imagination power, you can overcome those challenges pretty easily. That's what I feel. Okay. And the other point is your consulting ability. Now, the consulting ability is, I think, a lot of you people are with experience. You have the experience of consulting, right? And that's what actually helps you to establish your perceived value, right? How good is your work or success? No matter what you have done, if you're not able to consult, demonstrate, and present, people will say, okay, well, I don't buy this. Okay. So the one single point again from this entire thing, okay? So that is like, see, I mean, you no matter how many, you are working in IT, you are working in some retail, CPG, or you are working in some different domain, psychology or whatever. At the end of the day, you are trying to solve some kind of problem, right? So in analytics, you are going to solve a problem. So if you know how to solve problem, surely you are welcome in analytics, and you learn some of the means of solving those problems in analytics, and you'll be able to do it. So don't avoid problems, love them.